we're going to use properties to find exact values. So this first slide you don't need to write down, it's already in your notes. Just some of the properties we've learned. A logarithm base a of 1 equals 0. A logarithm base a of a equals 1. Those inverse properties, the one-to-one properties, but we've already used in this chapter. Along with these properties here. So let's get into our first example. We want to find the exact value of logarithm base 5 of 1 over 125. So I'm going to notice that this is a base of 5. So I'm going to try and see if I can rewrite 125 as a base of 5. So I say logarithm base 5 of, and I'm going to rewrite that 125 as 5 times 5 times 5, or 5 cubed. Then I'm going to rewrite that 5 to the third with a fraction. Remember, when you have 1 over x, you can rewrite it as x to the negative 1, and that's what I'm going to do next. So I'm going to change it from a fraction to a negative exponent, so 5 to the negative 3 power. Now I can use the inverse property back on this slide here. If you have a logarithm base a and an exponential base a, then you're just left with whatever that exponent is. So our logarithm base 5, exponential base 5, so our answer is going to be negative 3. So our exact value for this logarithm is negative 3. Second example. Now we have a logarithm base 2. So I'm going to first rewrite this radical as a power. So I say logarithm base 2 of 8, and I'm going to change that radical to a fractional exponent, 8 to the 1/5 power. Then I'm going to use the property where I can move that 1/5 power down in front. So now I have 1/5 times a logarithm base 2 of 8. Now I notice my logarithm is base 2. I want to change that 8 to an exponential base 2. So 8 can be rewritten as 2 times 2 times 2. So I'm going to leave the 1/5 alone, the logarithm base 2 alone, and I'm going to change this 8 to a 2 times 2 times 2, or 2 cubed. Now I can use that inverse property again. I have a logarithm base 2, an exponential base 2, so this whole piece right here now becomes a 3. And then I still have this 1/5. So now I say, what is 1/5 times 3? And that answer is 3 over 5 multiplied. Last example in this slide. Just going to move it down a little bit here. All right, so now I have a logarithm base 4 and another logarithm base 4, and they are subtracting each other. So I can combine them back into one logarithm by dividing 32 by 2. So logarithm base 4, and then I take 32 and I divide it by 2. Now let's go ahead and complete that fraction by simplifying it. So 32 divided by 2 is 16. And then I still have this logarithm of base 4 of 16. Now, since my logarithm is base 4, I want to rewrite 16 as an exponential base 4. So what two numbers with base 4 would give us 16? So logarithm base 4, and then I can rewrite that 16 as 4 times 4, or 4 squared. Now I have the logarithm base 4 and exponential base 4, So my final answer then, everything else cancels out because these are inverses of each other. I just have an answer of 2.